Hi class, in this assignment we're going to do a couple of proofs that actually show that the formulas are correct, the formulas for derivatives. And let's take a look at the first one. So the main idea is that we're going to be proving using the basic definition, except that we're going to use the basic definition to prove an actual formula or a shortcut. So for the first one, it's just a constant, and what we're proving here is that the derivative of any constant, it's technically zero. So what I'm going to do is I'm just going to let f of x equal to c, and then where c is any real number. And then keep in mind that on the background, we technically have the following. So we technically have that if it happens to be any real number, the function, it's basically a horizontal line. The slope of a horizontal line, it's equal to 0. So this is technically y is equal to f of x, which is c. Now we're still going to be applying the limit definition. So in this case, we're just going to be applying the f prime of x. So f prime of x is equal to the limit as h approaches 0 of the following. And I'm just going to rewrite the actual function notation and then substitute the proper value. So in this case, this is going to be the f of x plus h minus the values of f of x divided by the values of h. Now, as we do the substitution for the actual function, this is the limit as h approaches 0 of the following. Technically, if you were to pick any value x here, this is going to be f of x. And because it's constant, anywhere you pick an h, so if you were to do a length of h, it's still going to be f of x, which is equal to c. So this represents f of x plus h, which is equal to f of c, because you have a constant function. So when we're evaluating, so let me make this sketch a little bit better. So keep in mind that we have a horizontal line. And then as we're getting values, if this were to be x, this value here is going to be f of x. If you pick a constant value h later on, so this will be x plus h, you're going to end up with the same value. This is f of x plus h, which is equal to c. So when we're doing that substitution within the definition, we're simply going to say that, well, we're evaluating the limit, and this is going to be c. That represents your f of x, and technically that represents this value here, minus c divided by h. So on the good news, this one just requires a quick evaluation, and this is still the limit as h approaches 0 of technically 0 divided by h, and we simply end up with the values of 0. And let me just rewrite it. If f of x is equal to c, then f prime of x is equal to 0. And what we've done here is prove the actual statement with the actual function being a constant. I'm using the regular function notation as we're applying the definition. There's an alternative way of doing it with other ways of rewriting the same definition. In this situation, that's actually it for the first problem.